Okay, so we've all heard the buzz about vector databases, right? But how do you actually use one? How do you go from that cool concept to a real working application? Well, that's exactly what we're going to do right now. We're breaking down the core patterns and the best practices you need to build your very first vector app, step by step.
So let's kick things off with a problem that I'm sure drives us all crazy. You type something into a search bar, and it just gives you back results with your exact words, completely missing what you meant. It's so frustrating, isn't it? The search bar is just being literal. It's not being intelligent. Well, not yet, anyway.
In this right here is the big shift. Over on the left, you've got your traditional keyword search. It's basically just a word matching game. But on the right, that's semantic search. It doesn't hunt for words, it understands the meaning behind them. And that idea, that's the core of everything we're about to build. So let's dive into our first and probably most fundamental pattern, semantic search. Think of this as the foundation, the starting point for building apps that can genuinely understand what a user is asking for. What's so cool about this is how simple the process really is. It's just 3 steps. First, we generate embeddings, which is just a fancy way of saying we turn our text into numbers or vectors that capture its meaning. Second, we insert those vectors into our database. And third, we search that database not with keywords, but with the meaning of our question. It's a completely different way to think about finding information. And you see the results immediately. I mean, look at this. The query is, what stores vectors? And the top result is Vector-Databases store embeddings with a super high relevance score. Now notice, the question and the answer barely share any of the same words, but the meaning? It's almost a perfect match. That's the magic right there.
Okay, so we figured out how to find relevant information. Now, what if we could give that superpower to a large language model? That brings us to our next pattern, Retrieval Augmented Generation, or RAG. This is how you build those amazing chatbots that can use your own private documents as their brain. And the RAG pipeline? It builds directly on what we just did. First, you get your knowledge base ready, your company docs, your PDFs, whatever, and you turn it all into vectors. Then when a user asks a question, you use that semantic search we just talked about to pull out the most relevant pieces of text. Finally, you hand that context and the question over to an LLM and say, hey, answer this question using only these facts. And what you get is a chatbot that gives you accurate, factual answers from your data. The user asks about price, the system semantically finds the right sentence in your documents, and the LLM creates a perfect answer. It's not guessing or hallucinating anymore, it's using a source of truth. This is how you stop the model from just making stuff up. But searching by meaning alone is only half the battle. What if you need more control? What if you want to mix that conceptual search with some good old-fashioned hard and fast filters? Well, that's exactly what hybrid search lets you do. The idea here is actually really simple, but it's incredibly powerful. When you store your vectors, the things that capture the meaning, you also store structured metadata right alongside them. Things like a product category, a date, a price, or whether something's in stock. This metadata gives you a way to slice and dice your search results with absolute precision. So, for example, you could search for a fuzzy concept, like headphones with good audio quality. That's the semantic part. But then you can add filters to only show items in the electronics category that cost less than $100 and are currently in stock. You really get the best of both worlds, the conceptual understanding of vector search and the rock-solid precision of a traditional database filter. Okay, so building these patterns is one thing, but making them fast, reliable, and cost-effective for the real world, that's a whole other ballgame. Let's switch gears and talk about some absolutely essential best practices for taking your app from a fun prototype to a real production system. First up, and this one is huge, batching. Please, whatever you do, don't insert your vectors one by one. Each of those is a separate network request, and it is painfully slow. Instead, you've got to group them, hundreds or even thousands, into a single operation. This one tiny change can make your data ingestion pipeline ridiculously faster. Next up, caching. Look, generating embeddings costs time and money, usually because you're hitting an API. So don't do it over and over for the same piece of text. It's just wasteful. Use a simple cache. If you've seen that text before, just grab the vector you already made. It's way cheaper and a whole lot faster. So let's just quickly recap that production checklist. 1. Batch your operations for insane speed. 2. Cache those embeddings to save time and money. 3.
Always build in retries to handle network glitches. They will happen. And 4, use namespaces to keep your data organized, like keeping data for different users or products separate within the same database. So which tools should you actually go with? Here's a quick little breakdown. If you want something that's fully managed, you don't have to think about it, it just works and scales, look at Pinecone. If you're just messing around on your laptop, ChromaDB is amazing and super easy to use with Python. And if you need to host it yourself for maximum control, Qdrant is a fantastic option. The right tool really just depends on your needs and where you are in your project. Whew, we have covered a lot of ground. But knowledge is only useful if you actually apply it. So let's wrap this all up with a clear, actionable plan for what you can build like this week. So here it is, your mission, should you choose to accept it. First, build a basic semantic search over a small set of documents you care about. When you get that working, build a RAG chatbot on top of it. And finally, add some metadata to your vectors and implement a hybrid search with filtering. If you follow these steps, you won't just understand the theory, you'll have a real working application to show for it. You see, all of these patterns, they're really just about unlocking the value that's already sitting there hidden inside your data. It's about giving you the power to have a conversation with your documents. So I'm going to leave you with this final thought. You have the tools now. Your data has the answers. The only question left is, what are you going to ask it first?